Okay, this is the first problem we went over yesterday. Does anyone have questions about it? If you don't, just type like no in the chat or something, so I know that you guys can like move on. Yes, as in you do have questions or don't have questions. Okay. What about the rest of you guys? Okay, I guess since no one's saying anything, we can probably move on to the next problem. So I don't think we got completely finished with this problem, right? Okay. So how far did you guys get? Okay, so I guess like does everyone get like the basic idea for how we would solve this problem? Or like does anyone need like a refresher on what the problem is? Okay. Um, so basically you have a game which is like uh you have like let's say you have like three cups maybe, and then under one and then a shell starts underneath one of these cups. But like uh Elsie doesn't know where this shell starts. So then like let's look this input here. So here the three means there's three turns in the game. And then this first line means in the first turn, uh Bessie swaps these two cups. So then the shell would go from there to here. And then after the swap, Elsie would guess 1. And then in this case, she's wrong because this is cup 1, but the shell is in cup 2. So Elsie is wrong. And then afterwards, this means that in the next turn, Bessie swaps cups 3 and 2. So the shell would go from here. Oops. It would go from that cup to this cup. And then Elsie would guess 1 again. And then she's wrong again. And then finally, Bessie swaps cups 1 and 3. So the shell would end up in this cup. And Elsie's guess of 1 is finally correct this time. So she would have a final score of 1 because she guessed it correct 1 time. But basically, we want to know the highest possible score she could get. And notice that the problem does not specify where the pebble initially starts. So in order to get the highest possible score, you have to go through like every possibility, right? And then there's actually only 3 possibilities for this game, which is the shell starts under cup 1, it starts under cup 2, or it starts under cup 3. So essentially how we're going to solve this problem is we just process every possible starting point for the pebble and then like simulate the game and then check how many points Elsie is going to get from it and then take the maximum of these. So do you guys get this so far? Okay. So I guess if no one has any questions about this, we can probably like go on to do some code. Let's see. No. Wait, oops. I think I actually stopped sharing. Okay. So as usual, we want to include bits and then use namespace std. And then let's see what our input looks like. So we first input n, which is the number of swaps. So we have n, and then we input n, and then we have to input n 3 tuples. So we have to reuse these values multiple times since we have to like try every possible starting point, right? So what we're gonna do is we're gonna create 3 arrays, A, B, and G, to store like these values. So I'm gonna have 3 vectors, vector int an, bn, and gn. And what this means is you have a vector A of size n, a vector B of size n, and a vector G of size n. And then, so what we're going to do is for each of these n lines, we're going to first input A, then we're going to input B, then we're going to input G. Do you guys get that so far? Okay. And then what we're going to do next is we're going to have a loop that loops over every possible starting point. So it will be like in I equals 0, I equals 1, I less than or equal to 3, and I plus plus. And then we're going to have a variable called the current, which is the current cup that the pebble is under. And we're going to set this to I. And then now we're going to process each of these n swaps. So for int j equals 0. And notice that we can't use I again. We have to use a different variable, otherwise C++ will get confused. So we have j equals 0, j less than n, j plus plus. And what we're going to do is we're going to do the swap. So basically, let's say that the pebble is currently under cup 1 and we swap cups 2 and 3. This doesn't affect our current cup, right? So we don't need to worry about that. The only cases that we do need to worry about are when either A or B is the current cup. So we say if current is AJ is the swap that we're currently processing, then we should set the current cup to BJ. And then likewise, if current is BJ, then we should set the current to AJ. So like as an example, if our current cup is like, let me annotate. If our current cup is like 1 and the operation is swapping cups 2 and 3, then we don't need to worry about this, right? And then, but if it's swapping like cups 1 and 2, then the current cup should become 2. And if we're swapping cups 2 and 1, then the current cup should also become 2. Because like swap is two-way, right? So swapping cup 1 and 2 is the same thing as swapping cup 2 and 1. Okay, let me go back to the problem statement real quick. Okay. So then after this, we want to see if the cup that the shell is under is equal to Bessie's gas. So we have a variable int score equals 0. Initially her score is 0. And then if current equals Bessie's gas, Elsie's gas, then we want to increment the score. And then we have another variable answer here, which takes the max of all 3 possibilities. And then C++ has a built-in function called max. So like max AB would return the maximum out of the 2 values A and B. So if A is greater than B, then it would return A. And if B is greater than A, then it would return B. So then we can just have answer equals max answer, score. And then alternatively, you can just say if our current score is greater than the answer, then answer equals score. But this way of writing it is more concise. So I'm just going to use it. And then at the end, we just want to output our answer. So this should work. Let me test it real quick. Do you guys get the solution so far? Or do you guys need clarification? Three. Huh. Let's see. Okay, the answer here is 2, so let me see. Did I read the problem wrong? Shells A and B were swapped by LC. Okay, well, let's run through the problem real quick. So here it says if the pebble started under shell 2, then she guesses right twice. So if it starts under shell 2, then it starts here. So she gets the first guess wrong. And then wait. Oh wait, no. It starts under shell 2, and then these two get swapped. So then the pebble goes from here to here, and then she gets that right. And then on the second pass, 3 and 2 get swapped, so that doesn't affect it. And then the shell is still under 1, and then she guesses 1, which is correct. So that's also a check. So why does the program output 3? Let's see. Current value is equal to the guess. Let's see. So the typical method to use when debugging is to print out your variables. So let's see. So let's output the start. And then let's also output here. And then new one after that. So let's run this. So, okay, what this output is saying is when the shell starts under, when the pebble starts under shell 1, the 1 that's outputted here is from this line, which is where it starts. And then, okay. Oh wait, okay, let me put this line after this. And then, let's see. Okay, so this is saying that after the first turn, the shell is under, the pebble's under cup 2. Oh wait, the answer is correct now. Okay, wait, I'm confused. But yeah, let's just go through this output. So, this output is just saying when the pebble starts under cup 1, after the first swap, it ends up under cup 2. And then after the second swap, it ends up under cup 3. And then after the third swap, it ends up under cup 1. And then similarly, when it starts under cup 2, it's at 1 after the first swap. And then it's at 1 again after the second swap. because the second swap is swapping 3 and 2, which doesn't affect cup 1. And then it ends at cup 3. And then similarly, when it starts at cup 3, after the first swap, it's still at cup 3 because the first swap doesn't affect cup 3. And then after the second swap, it's at cup 2. And then after the final swap, it's at cup 2. So yeah, that's like the typical debugging strategy. Does everyone get this part? Like, feel free to ask about any part of this code that might be a bit confusing. Or if you do get it, just like type a 1 in the chat so I know I can move on. Okay, I have 1 so far. What about the rest of you guys? You guys can also just take a minute to like look at this code. Here's a link in case you guys want to take like a more in-depth look at it. Oh wait, I just realized I didn't send that to everyone. Okay, there's a link. I want the rest of you guys to I want to make sure the rest of you guys get it before I move on. And if you don't get it, then just feel free to ask. Okay. Okay. I'll give you guys like maybe like 2 more minutes to look at it, and then we can move on to another problem. Okay, I guess while the rest of you guys are looking at that code, I'll introduce the next problem. I'll send this link for you guys to like look at it and maybe like ask if you have any questions about the problem statement. Yeah, so for those of you guys who are done with this problem, just like take a look at the next problem and let me know when you guys finish reading that. Okay, for those of you who have finished the problem, does anyone want to share like their ideas on like how to maybe solve this problem? No one has any ideas? Okay, I'll give you guys maybe like 5 more minutes to think about this problem. Do we have class next week? We have class on Monday, and that's the last class. Okay, do you guys have any like initial thoughts about this problem? Or does anyone still have questions about the previous question? First thoughts, anyone? Anyone need clarification on what the problem means? I assume everyone is either like really stuck or just already done with the problem. Does anyone have like any semblance of an idea for this problem? Like any idea is fine. It doesn't even have to be correct. Okay, I guess I'll explain the sample test case first. So this 5 means that there will be 5 jewels and 5 diamonds, and 3 means that the maximum difference between any of the diamonds Bessie displays is at most 3. And then in this case, the most amount of diamonds she can display is 4, which she can achieve by, for example, choosing diamonds, this diamond, this diamond, this diamond, and this diamond. Because the maximum difference between any of these diamonds is 1 and 4, which have a difference of 3. And 3 is still an allowed difference. So she can have up to 4 diamonds in the case. But notice that she can't include 6 here because the difference between 1 and 6 would be 5, and 5 is greater than 3. So she can't include this diamond. So yeah, she can include at most 4 diamonds. Do you guys get this? Just type like a 1 in the chat again. Okay. One person? Anyone else? Okay. Um, so like, I guess a good question to think about is like, what would be like a way to process every possible like case? Like, what do you guys think? How about like more specifically, if we fix, like if we decide on if we decide that one of these diamonds will be the smallest diamond in the case, how can we find the largest case we can make? So like let's say we decide that the smallest diamond will be of size 1. Then how do we determine like if out of all of the cases whose smallest diamond is has size 1, what's the largest of these cases? How can we determine that? Like let's go up through all the possibilities, right? If the smallest diamond is 1, if the smallest diamond is 1, then we can either have um just this single diamond, or we can have 1 and 1, these two diamonds, or we can have 1 and 3, or we can have 1 and 4, or we can have 1, 1 and 3, or we can have 1, 1 and 4, or we can have like 1, 3, 4. But the biggest case uses all of these diamonds. It's 1, 1, 3, and 4. So what you notice is that any diamond whose size is between 1 and 4 should be used in this case. Do you guys get this so far? $56? Oh, 5 and wait, Sherry, what do you mean? Oh, well, in the input, there's no 5. Like, okay, what this input means is Bessie can pick from a diamond, like the diamonds Bessie can pick from are like one of size 1, there's one of size 6, there's one of size 4, there's one of size 3, and there's one of size 1. Like there's no size 5 diamond. You get that? Right. Okay. Um, and then like, so this is like the answer, right? Why not 5? Well, there is no size 5 diamond. Oh, you mean like why is the answer not 5? Or what do you mean? Oh, why can't you include 6? That's a good question. Like, why can't the set be 1, 1, 3, 4, 6, right? Well, the difference between the size of diamond 1 and diamond 6, that's a 5-point differential. And 5, and the maximum allowed difference is 3. So you're not allowed to include 6. That's a good question. Does that make sense? Okay. Um, and then let's say our smallest value is 3. Like, even though this isn't the best answer, just hypothetically, let's say the smallest value was 3. Then what's the biggest set we can form? Feel free to answer in the chat. If the smallest value of the case is 3. So I guess first off, if the smallest value is 3, then what's the largest value we're allowed to use? Yeah, someone said 6, and that would be correct. So if we can use all values between 3 and 6, what's the most diamonds that can be in the case? If we're allowed to use all values between 3 and 6. Or in other words, how many of these numbers are between 3 and 6? Uh, inclusive. So like you're also allowed to use 6. You can use both. You can use 3, 4, 5, or 6. So how many of like those values are in here? Yeah, 3. That would be these 3. Um, so that means if our smallest value is 3, then the best we can do is a case of size 3. And here we have a case of size 4. Okay. So and then you apply a similar process to if the smallest value is 4 and the smallest value is 6. So like if the smallest value is 4, how many will we be allowed to use? Yeah, it would be 2. And then if the smallest value is 6, then it would be 1. So out of all these values, the greatest one is 4. So, okay, what does this lead us to? Well, we can just loop over all possible values for the smallest value in the case. So like we're like, oh, let's say the smallest value in the case is 1. Then you write some code to calculate like the maximum case code. And then next you say, oh, let's say the smallest value has to be 6. What's the best we can do? And then you do this again. And you repeat this process for every possible value for the smallest diamond. And then, okay, so like, let's say we fix our smallest value to be x. Does anyone have any idea for like how to write code to find the largest case that has the smallest value as x? I'll give you guys maybe like 5 minutes to think about this. It's like okay, like as an example, if x is equal to 1, then we have largest case whose smallest value is equal to 1. And in this case, we're allowed to use any diamond with size between 1 and 4, right? Also write this as 1 plus 3, where 3 here is just k. So try to generalize this to any value for any possible value for x and k. Like what would our allowed range be? Yeah, definitely use a for loop. You're on the right track. So does anyone want to tell me like if our smallest value is x? Let me write this. If smallest value x and max allowed difference is k, then what would this range be? This allowed range. Oh, and for like those of you who don't know, this notation, bracket LR, represents the range between all numbers from L to R inclusive. So like including L and R. So if our smallest value is x and the max allowed difference is k, then what's the range of values that are allowed? Anyone can answer. Like when we had x equals 1, yeah, that's correct. It's from x to x plus k. So going back to what Sherry suggested for for loops, yes, you should definitely use a for loop. So basically, we're going to loop through all these diamonds and check if the value is between x and x plus k. And if it is, then we can include it in the case. So, okay, I think at this point we have basically like the entire code for like a full solution. So, but before I like actually code it, I just want to ask if anyone has any questions. Or if we can move on. Okay. So let me clear this. Also, one more thing to note. Notice that this problem says input format file, while the other problem says input arrives from std in. What std in means is basically you can see here we use cin. That's what std in means. But in older USACO problems, we get input from a file instead. So we're gonna talk about that later. But for now, I'm just gonna write the code. Okay. new file, diamond collector. Okay, so yeah, we're including our library first. And then in our main function, the first thing in the input, the first two things in the input are n and k. So we have n, k. We input n and k. And then after that, we want to read these diamond values into an array. So we have a vector diamonds with size n, and then 4 into I equals 0 through n minus 1. We're gonna input diamonds I, and then so we're gonna loop over every possible value for the smallest diamond. So oh, actually, I kind of wanted to use an example for an enhanced for loop. So diamonds I. So basically what this notation does is it loops through every value in diamonds and then stores it in smallest. So then let's say for in diamonds. Also, like, notice that also like this notation is basically equivalent to saying for in I equals 0, I less than, wait, hold on. Let me write this as a comment real quick. I less than smallest. So like this and this are basically the same. Well, not basically, they are exactly the same. If anyone has questions about this, feel free to ask. And then, okay, and then we also want to store another variable in case size equals 0. And then for each diamond, you want to check if, first we want to check if it's, okay, we want to check if diamond is in the range smallest to smallest plus k. So this condition is basically if diamond is greater than or equal to smallest, and notice the two and, diamond is less than or equal to smallest plus k, then we want to increment the case size. And then, all right, we need to store another variable answer. And then in the end, we're just gonna say, we're gonna update answer. So if case size is greater than answer, then answer is case size. And remember, we can also just write answer equals max answer case size. And then at the end, we're just gonna output our answer. So let's get our input. 5, 3, yeah, okay, and then we're gonna run it. 1, okay, that is not correct. Let's see where we went wrong. If diamond and diamond is less than this, then we should implement the case size. Let's see. Let's just print every case size. Oh, wait. I just realized. Okay. Okay, that was a technical issue. Okay, so our answer 4 is correct. But if we try to submit this, okay, wait. Okay, if we download this and let me log in. If we submit, we get this error. Your output file is missing. And this is what I said earlier about file input and output. And I won't get too much into the details of this, but if you're like solving USACO problems later and you run into this error, here's how you fix it. So you paste this here into here, and then you write R. R stands for read because you're reading in the file into the program. And you want to read it to stdin. And then similarly, you want to paste this here, and then W stands for write because you're writing to this file, and then you want to redirect that to std out, which is the same thing as C out. So let's download this and let's see if it works. Okay, so this code works. Also, sorry for running a bit over time. I'm gonna send you guys this code and you can like consult it on your own free time. And if you guys have any questions now, also feel free to let me know. Yeah, pretty cool, right? Yeah. Okay, if the rest of you guys don't have any questions, you can feel free to leave. But if you have any questions, I can stick around. Thank you guys.